All right, we're at 2 minutes past the hour. Let's go ahead and start. Anybody else can join us along the way. And Sam, do you mind confirming that you can see my screen just to make sure that I'm showing content?
Yeah, all good.
Beautiful, thank you. All right, let's get started. So just like to say hello to everybody once again, and thank you guys all for joining us for today's webinar. The title, subject of today's webinar is Introduction to Mobile Handheld Laser Scanning. It's really the core of what GeoSLAM does. This webinar is targeted towards those who are kind of new to this technology, newer to this technology. I won't get too in the weeds on some of these explanations, or at least I'll try not to. Basically, if you want to learn more about kind of the basics of this technology, how it works, how to use it, kind of an overview of our products and what's out there, this webinar is for you. If you already are quite experienced, please still tune in to the webinar. There's going to be a lot of good information about GeoSLAM technology, maybe some updates to things that you haven't seen already. If maybe you bought a system a year or so ago, a lot of this content towards the end of the presentation will be new for you. So please stay on the line and definitely ask any questions that you want along the way. So introduce myself. My name is Brian Rosensteel. I'm a senior solutions architect with GeoSLAM based in the Western United States. I live in California. But I serve our Western U.S. region and kind of help out wherever I'm needed. I do have quite a bit of experience in this field using LiDAR technology. I was an end user of GeoSLAM products before I joined the team. But before that, I was working mostly on the services side, primarily in the AEC industries, architecture, engineering, construction industries, doing scan to BIM work, but also worked in a lot of different other types of capture. So I'm quite experienced with this technology and how to utilize it. My email is listed here. If you do want to jot that down, especially if you're in my region, you're welcome to reach out to me anytime or connect with me on LinkedIn. Always happy to have different people following me and communicating and collaborating on different things. So feel free to reach out. So quick agenda here. We're just going to go over basically what is laser scanning and how does it work. What is mobile laser scanning as well? How does mobile laser scanning compare to static laser scanning, which is what I refer to as the traditional method of laser scanning, if there is such a thing. And then talk a little bit more about how to use this technology, how other companies are using this, some examples of data that we've captured and deliverables that we've created from that data. And then just talk a little bit more about GeoSLAM, talk about our products, talk about how we process data, talk about accessories for our systems, and just kind of some of the future updates as well. So that's kind of for the people who might be more experienced or already current customers of GeoSLAM. You can see what we've been working on in the last few months. All right, so the first question, most important question is, what is laser scanning? If you're not familiar with laser scanning, you might have an idea of what it is and how it works, but we'll just kind of dive into what this technology is and sort of how it works at a high level. A lot of people do refer to laser scanning as LiDAR. That's an acronym for light detection and ranging. I personally don't like that acronym very much because it's kind of difficult to understand what that even is just from that description. I prefer to use the term laser scanning, but they're fairly synonymous with each other. But essentially what laser scanning is it's a process of using laser-based survey instrument to collect data points, usually millions of data points. So essentially it's a LiDAR sensor will shoot out a laser. It will collect a distance reading in three-dimensional space off of an object, a surface, a feature, whatever you want to call it. It will bounce back to the sensor and collect that three-dimensional data point. And typically we're doing that hundreds of thousands of times per second. And basically what it's doing is it's recreating the environment around you as these millions of data points. And basically it's reproducing that environment in an accurate way digitally, creating what we call digital twin. Now that's also kind of a buzzy word. Digital twin is used to describe a lot of things. Basically any recreation of a virtual environment can be referred to as a digital twin, like BIM models, CAD models, even virtual tours, things like that can be considered digital twins of environments, photogrammetry, that kind of stuff. if you're familiar with any of those, but this is a form of creating a digital twin, but not the only form of creating a digital twin, obviously. So typically the output of laser scanning is a three-dimensional point cloud. We have a couple of examples on the right here of point clouds. The one at the top right is actually the Christ of the Redeemer statue in Brazil. We scan that inside and outside using UAV, and then obviously handheld inside, and you can kind of see that see-through mode. It's one of our favorite captures to show, and then sort of a more traditional capture of the exterior facade of a building and the site around it below that. But essentially, once we have this three-dimensional point cloud data set, we can do a lot of things with it. Some people choose to convert that into a surface mesh, which is essentially triangulating between those millions of points, typically reducing that down in data size and then triangulating between those millions of points to create a surface model, as opposed to using the point cloud itself, or maybe in addition to. But once we have this basically three-dimensional representation of our environment, we can do all kinds of things with it. We can measure from it, just any conceivable measurement within that space. You can pull from the data. We can get takeoffs. We can estimate from it. We can calculate volumetrics. We can create documentation from it. We could design off of it as well, because it is an as-built document, an accurate as-built document of that space. We can use it for visualization. People use this kind of data a lot in the gaming industry to recreate virtual environments. A lot of times they are converting to a mesh when they're doing that. Spatial analysis, just understanding how much space you have and how you're utilizing it. Inspections, we can take the system and put it above ceilings or below ground or in vertical shafts and things like that and inspect them. That lends itself to a lot of engineering and construction applications. In construction, we can also do progress monitoring. So continuously scanning a job site and monitoring the progress on that job site, and also verifying how accurate things are being built in the field. It's a really common application in construction. Also just more traditional workflows, creating CAD drawings off of it, creating BIM models off of it. The list goes on and on and on, but these are just some of the ideas that some of the primary use cases for this point cloud data once you have it in your hands. Typically, that's being done in a third-party software, especially when we're referring to GeoSLAM technology. We really are creating and preparing the data to go elsewhere. So whether it's in Autodesk or Bentley Systems or Esri or wherever it is, you're doing it in a third-party software, typically, with only a few exceptions. So what is mobile laser scanning, right? It's basically the same thing, but we're doing it on the move, right? It's a system that is using LiDAR sensor that we can move with and capture data continuously, as opposed to from any fixed position, which is what we call static laser scanning. And I'll compare those on the next slide. But mobile laser scanning really gives the operator the ability to move freely with the instrument, and really opens up a lot of possibilities, allows you to capture data a lot more quickly as well, which is one of the primary benefits of mobile laser scanning. Some of these systems, like our Revo RT, have the ability to process and stitch that data together using the SLAM algorithm in real time. That's what the RT stands for the Revo. Or some, like the Zeb Horizon, are capturing that raw data, and then we're doing the SLAM processing in the back end. I'll talk about SLAM on the next slide. So if you don't know what that is, we'll talk about that in just a second. But it really gives you, with a handheld system, or primarily a handheld system, it gives you a lot of versatility, right? Just because we designed it as a handheld system does not mean that's the only way that you can use it. You can take our system, especially the Zeb Horizon, and mount it on a vehicle. You can use it handheld. You can put it on a UAV. You can put it on a backpack. The list goes on and on. Extendable poles, cradle systems, so on and so forth. Gives you a lot of versatility to use it in a lot of different ways, in a lot of different environments, to capture a lot of different data. But really the important part of that, or the part that really matters, at least this is my opinion, but is SLAM. If you're not familiar with SLAM, you might have heard it. It's in the name of our company. It's very important to our technology. But SLAM is an acronym. It stands for Simultaneous Localization and Mapping. Basically what that is it's kind of the secret sauce behind this technology, right? The hardware, LiDAR sensors and other kinds of sensors are fairly easy to sort of slap together into a system, but what you do with that information is what's really important, and what really creates a lot of value to the product. And We kind of pride ourselves on having the most robust SLAM algorithm. We originated this technology and we've really put it through its paces and tested it in all sorts of different environments and have created very, very versatile products based off of our SLAM algorithm. But essentially what it is it uses this raw data from a variety of different sensors, but primarily a LiDAR sensor, which is the laser scanner, right? It's basically mapping the space around you with that scanner. And then as you're moving, it's identifying features, surfaces, objects in the space. In a built environment, it's furniture, walls, doors, ceilings, floors, windows, doors, things like that. In an organic environment, it's the ground, it's trees, it's bushes, it's rocks, that kind of stuff. What those features actually are don't really matter, but you need features around you in order to effectively utilize SLAM. But we're basically constantly determining our position based off of those features. So we start from a fixed position, we pick the scanner up and we start walking with it, moving with it. And then it's continuously identifying those features and tracking our relationship to those features as well. And basically, if you see down at the bottom, we can continuously map an entire space and basically recreate that environment using this continuous stitching of data. If you're familiar with static laser scanning, essentially what we're doing is cloud-to-cloud registration on a continuous basis. And it really gives you the versatility to move through an environment. Now, we also reinforce that with other sensors like an IMU, which is an inertial measurement unit. It's basically reinforcing what it is that we're capturing with the LiDAR sensor. And other mobile scanners might use other types of instruments as well to reinforce that SLAM that's being run on the LiDAR data. So static versus mobile scanning. This comes up a lot. I refer to static as the traditional way of doing laser scanning. I'm not sure that's true, but basically the big comparison between these two is, static scanning is static. It's from a fixed position. Typically you're mounting it on a tripod and you're moving it from location to location to location, and you have to have overlapping data or overlapping targets between those positions, and you're kind of stitching them together, chaining them together in order to create a continuous data set, capture an entire environment. Basically, mobile scanning is doing that on the move, right? And we're using that SLAM algorithm to stitch that data together, to piece all of that data together into one continuous data set. So that's kind of the primary difference between the two. Some of the pros and cons of static versus mobile scanning. Static scanning in general is more accurate, right? We're capturing from a fixed position, so it's easier to be accurate and precise. Typically, we're getting a little bit more of a dense data set as well, because again, we're capturing from a fixed position and not on the move. And typically, we're also getting a longer range. That's not always true across the board, but your average static scanner has a longer range than your average mobile scanner. On the mobile scanning side, we're a little bit less accurate because we're capturing on the move. We're a little bit less dense because we're capturing on the move, and we've got a shorter range. Typically, that's not always the case. With a static scanner, on the con side, you really need a skilled operator, right? You need to have some survey experience. You need somebody who really knows what they're doing, and sometimes that process can take months or years to really hone that skill. It's something that I learned throughout my career, but it probably took me at least a year to feel really, really comfortable with what I was doing and feel like I was an expert using that system. Because you're moving this thing throughout and you're kind of piecing these together, you're talking about a longer field time, longer processing time. Usually the process of stitching that data together is quite manual. There's some semi-automation being developed by a lot of the hardware manufacturers of static laser scanners, but it's really still quite a manual process to put everything together and just make sure that you have a good, reliable data set. On the mobile scanning side, really anybody can operate a mobile scanner. There's some things that you need to understand about the scanner to operate it effectively, but it's fairly easy to use. I can typically train somebody to use a mobile scanner in about 30 minutes, maybe a max of an hour. Because you're moving as you're scanning, it's shorter field time, shorter processing, and the processing is automated. That SLAM algorithm is really doing the heavy lifting. You don't necessarily need somebody who's got surveying experience, who understands these surveying principles to process this data. You're just taking a raw data set and dumping it into a processing software and letting it do the work for you. And then kind of depending on how you look at it, Mobile scanners typically have smaller data sets, and static scanners typically have larger data sets. Again, not true across the board all the time, but in general, that is true. So this is kind of a classic example of comparing static scanning versus handheld scanning on the same project. This is a project that I actually did personally. I won't tell you which static scanner we're using. It's not really relevant, but basically we scanned the same one story of an office, kind of a typical office space. I believe it was about 15,000 square feet, if I'm remembering correctly, with both a static scanner and a mobile scanner, and these are the results that we got. So with the static scanner, we did 125 scans. Each scan was a couple minutes, including time to reset the scanner, that kind of stuff. We did cloud-to-cloud registration, so we didn't have to move targets or anything like that, but sometimes that can add extra field time as well. So about 5 hours of total field scanning time. And then in post, to get all that data QC'd, registered, exported out, all that kind of stuff, we're looking at a few minutes again per scan. That is quite a manual process as well. We didn't use some of the automated features that could speed this up a little bit, but not a lot. So still, to get that data out, basically put all together, export it out to universal file format so we can bring it into, say, Autodesk. We actually did model this one. That took about 12 hours. So total time to create the point cloud was about 2 workdays, a little over 2 workdays. And accuracy-wise, we get 1 centimeter globally, which is from one end of the building all the way to the other end of the building. We got about 1 centimeter of accuracy. And then local accuracy, if we're measuring the width of a room or a door frame or a hallway, something kind of on that smaller scale, then we're looking at a couple of millimeters. So we'll look at that with a mobile laser scanner. We scan this with the Revo RT system, which is ideally suited for capturing indoor environments like this. We did 1 continuous capture, which was about 30 minutes long. Just a quick disclaimer, that's a little bit too long to scan typically with a mobile scanner, at least with a GeoSLAM mobile scanner. Probably should have broken that up into 2, but I was trying to push the system a little bit. 30 minutes of continuous capture time. And then post-processing, just getting that data into our hub software, registering it, QCing it, exporting it out, took about 30 minutes again. So total of about an hour of time to get that point cloud finished and in a format where I can bring it into AutoCAD or Revit or wherever we want to take it. So you're looking at about a 17-to-1 comparison when it comes to time, right? It took 17, 18-to-1 almost hours to scan it and get a finished point cloud with a static scanner, and then about an hour to do that with a mobile scanner. Now you're sacrificing a little bit of accuracy, but global accuracy from one end of the building to the other is still a couple centimeters, and local accuracy is still about half a centimeter to a centimeter. So you're sacrificing a bit of accuracy, but those accuracy standards are well within the tolerances for many, many applications, creating as-built documentation, creating BIM modeling, things like that. Not across the board, but I would say the vast majority, at least in my experience. So it might seem obvious, but the reasons that we use handheld laser scanners, or we're kind of pushing towards using handheld laser scanners or mobile laser scanners, is because they save time. And when you're saving time, you're saving money, you're saving resources, you're saving computing power, you're saving travel costs, whatever. It kind of starts to compound a lot because you're scanning so much faster, capturing data so much faster, doing a lot more volume of work as well, which allows you to make more money, hopefully. And the versatility, right? We can take this system pretty much anywhere. We can take it inside, we can take it outside, we can fly it on a drone, we can take it underground. The sky's the limit. The versatility really adds a lot to the value of the technology. Just to kind of elaborate that on that a bit more, here's a bunch of examples of ways that we've used our scanners in the field. I'm not going to go through all of them, but for instance, we can take the Zeb Horizon and ski down a mountain with it and capture good data. We actually have that data on our website if you'd like to view it. Geologic purposes, we had University of Arizona using the Zeb Horizon in Iceland to document the volcanic eruptions. They were out there every single day monitoring the progress and the change in the landscape during the eruptions. We can use it in construction to capture buildings. We can use it in underground mines to capture underground infrastructure or open pits or stockpiles, anything like that. You can see various examples here, but It's a very versatile system and works in all environments. And the process to put that data together is really no different from one environment to the next. It's more or less the same operation, just keeping sort of the same principles in mind while you're using the system. So also we can do really easy transitions in environments, right? We can go from above ground to below ground to confined space. And this is a really nice example of a Civil War tunnel in Spain, I believe. 15-minute capture with the ZEB horizon over 145 meters, so a few hundred feet. I'm going to play this real quick and let you guys take a look at the data. All right, you gotta love that dramatic music, but that was a really nice use case of how we can use GeoSLAM technology in a variety of different environments. Also, just a quick shout out to Nubagon. That's the software that we use to create that fly-through. We've used them quite extensively for a lot of our fly-throughs, so take a look at their software if you're interested in creating something similar. So just to kind of highlight some of the industries that are using our technology, and this is just kind of the main ones. There's probably 50 plus different industries that are using this technology, but it's pretty diverse from architecture, engineering, construction. That's what AEC stands for. We've got many universities using this for education and various departments that kind of tie into these different industries. Forestry works really well in organic environments and capturing forestry data. Surveying data, just kind of traditional survey of land or buildings, things like that, ties really well into survey networks as well, control points and things like that. We'll talk about a little bit more in a second. Utilities, power lines, government, police forces are using this, municipalities are using this, Department of Defense uses this for things I can't disclose. Transportation and logistics. Those just cover some of the main ones, but there's, like I said, probably a long list of industries that use this technology in their workflows. And here's just a couple of pull quotes from some of our customers, especially those in the AEC space. I'll let you read these yourselves, but kind of the gist of the feedback that we get from most of our customers is that our systems are easy to use. They're easy to grow your operations around. So many of these companies, start with buying one system and end up buying several of them and kind of grow their business around utilizing this technology. Saves time, saves money, saves resources, all while maintaining a high degree of accuracy, versatility, and reliability. So if you would like reference to any of our customers that are in your industry, we'd be happy to provide those. These are just simple quotes from architecture, engineering, construction industry. I've got another video here that kind of shows the Zeb Horizon in action. This was done of Boston City Hall, both inside and outside, and this one's only about a minute long. So. Excellent. Shout out to marketing team for that video. That's a great video. Like the music on that one a little bit better too, just if it means anything. So just want to talk a little bit about scan to BIM. These two technologies really kind of work in conjunction with each other quite seamlessly, and GeoSLAM really gives you the tools to do this process a lot faster and save you a lot of time in field capture. So just wanted to show, kind of highlight some projects that we've done as a company with our customers in the field of scan to BIM, which is essentially the process of taking this data and turning it into an informational 3D model. Just on this page, we have examples of 15-story building captured top to bottom and exterior as well with the GeoSLAM system. Actually, the one at the top right is the data set that I showed you earlier. That's kind of a crosscut of the Revit model that we created from it. Boston City Hall, the data set we just showed you, is down at the bottom, and then some above ceiling capture as well. Being able to capture above ceiling and ceiling voids is really easy with the GeoSLAM system, and then modeling duct and electrical and plumbing and things like that above ceiling is quite easy from our data as well. But a few more, I guess, before we talk about a couple more use cases here, I wanted to talk about our GeoSLAM Draw package. So GeoSLAM Draw is basically a software package that allows you to take this point cloud data and create views and kind of prepare your data, as well as extract information like line work and even 3D BIM model elements from your data, and then put that into a third-party platform like Revit or Bentley or ArchiCAD, things like that. So we offer a few different modules of this. Kind of the basic version is the start module. Plan module allows you to do a lot of 2D workflows. The BIM module allows you to go more into 3D and extract 3D elements. Mining has some tools around volumetrics and other meshing and things like that we can do for the mining industry, and then the Pro package pretty much gives it all to you right away. So very, very powerful software. Definitely look into it a little bit more on our website, and I'm happy to do a demo anytime if you would like to see more about this Draw platform. But it's one of the kind of crucial components when we're doing scan to BIM work, and I use it pretty much for every scan to BIM project that I work on. This is one that I personally modeled myself. The next one I also modeled myself, but I've got probably half a dozen examples of projects that I've personally modeled alongside of demos that we've done. Just for data sets that we can show off. But this is a villa in the Czech Republic, 8-minute scan time. I believe it was scanned with the Zeb Go system, kind of our entry-level system. and it took me about a day to take this data and model it into the model you see here all the way on the right. But the crucial step in between was bringing it through our draw BIM package and using that to align the data, so basically square it up, export it out to Autodesk recap format, as well as creating 2D slice views through the data to model off of. And then I also, of course, use the point cloud as well to model off of. We can also, with this Draw BIM platform, extract things like walls, doors, windows, basic architectural elements, and send them over to your Revit model. So there's an interoperability between Draw and Revit, as well as a couple other third-party applications as well. This is another one that I did a little bit larger scale of a 3-story hotel that's located in Southern California. This was 5 scans done with the Zeb Horizon, all registered to each other with our merge tool, and then run again through the Draw BIM package to prepare that data to go over to Revit. And again, I did use it to pull some walls and doors and windows and things like that to get kind of the framework of the building, and then finished it up over on the Revit side. Took me a couple hours to scan the project, maybe another couple hours to get the data all processed and into Revit, and then the actual modeling side was 2 or 3 days, if I'm remembering correctly. Unfortunately, can't really save a lot of time in modeling. The Draw BIM package does help speed up that process, but that is still largely a manual process. There are some third-party tools that do what we call feature extraction, automated feature extraction, so pulling walls, doors, windows, things like that from the scan data, and we integrate with them. But the closest that we have is sort of a semi-automatic feature extraction with our Draw BIM platform. But bang for your buck, it's a really good tool to use. And just to kind of introduce you to our Zeb family, I'm not going to get in the weeds on specs and things like that of these systems, but we have 3 kind of core systems that we offer, starting with the Zeb Go. It's kind of the first step into handheld SLAM technology. It's our most affordable kind of entry-level system. Similar to the Zeb Go, we have the Revo RT. It has very similar specs, but the biggest difference is that the Revo RT is processing and stitching that data in real time. It also gives you the ability to connect a mobile device to the system, and via Wi-Fi signal, you can actually watch your progress through that space. So if you're doing interior spaces, it's a really nice system to use to make sure that you haven't missed anything, that you've properly tied your data together, that you haven't gotten lost. I actually have used it a couple times to get unlost in the building while I'm scanning. And then we have the Zeb Horizon. I kind of refer to that as the big brother of the Zeb family, but it has longer range, higher point density, and works really, really well in almost any environment, but its primary focus is outdoor, larger scale projects. And because we have so much more data, it also has very robust SLAM processing, so we can use it for a lot of different versatile types of capture, like you saw in some of the previous slides. And just to highlight some of the accessories that we offer for our systems, we can do lots of different things like adding imagery to the data with Zeb Pano or with a Zeb Vision. Zeb Discovery also adds imagery to the data. I won't get into the nitty-gritty details of each one of these systems, but basically what we're able to do is add visual reference as well as doing colorization of the point cloud based off the data. And just wanted to highlight our Zeb Vision, which is our newest camera accessory. It's kind of best of both worlds. So it's creating visual documentation as well as colorizing your data with a 360 4K camera. We have some accessories to get into hard to reach spaces like extendable pole. You can use that to capture above ceiling or even underground manholes, things like that. Really kind of any hard to reach place, or just capturing from a higher vantage point if you're capturing a stockpile or something like that. For more vertical infrastructure, we have the cradle system, which allows you to lower this system down in a vertical shaft and capture pretty deep vertical shafts for inspections and things like that. Then we have car mount and UAV mount, which allows you to take the Zeb Horizon system and drive with it at a speed of up to 25 miles an hour. UAV, same kind of thing, but capturing from the air. And then we also have Zeb Locate, which allows you to geo-reference your data, which is taking your data and putting it on a real world or a global coordinate system using a GNSS receiver. And you can use any GNSS receiver with this system. We have a couple other methods of geo-referencing the data as well, using control points and things like that, but Zeb Locate is kind of the simplest, most streamlined way to do that. And also wanted to talk quickly about GeoSLAM Connect. This is our newest processing platform. We just released it back in September, and we've been doing a lot of work and a lot of development on this tool, and we'll continue to do so in the coming months and years. But we have some updates. We have a newest version of our SLAM algorithm built into Connect, so it's going to give you the most robust SLAM processing available on the market today. Increased and enhanced 3D visualization, so QCing and visualizing your data is much more robust than it's ever been before. We also have tools like filtering and automating workflows, and the ability to integrate into third-party applications. Again, I'm not going to get too in the weeds on what Connect does, but I highly recommend you take a look at Connect on our website. And again, I'm happy to do a demo of Connect for anybody who's interested. But yeah, so just a kind of overview of Connect, basically how it works and how simple it is. It's really kind of 4 easy steps, right? We capture the data using the system. We take that data, we dump it into the Connect platform using kind of predefined workflows or setting up your own workflows to automate that process. So you're not clicking a bunch of buttons, you're basically just feeding it data. And then within minutes, you can view that data, QC that data, do some post-processing on that data. And then from there, we can export it out to a universal file format or bring it through our draw platform in order to create additional deliverables and things like that from the data. But the end goal is to get that data out into your platform of choice, whether it's an Autodesk or an Esri or anything like that. We can partner with a lot of different third-party applications. And here's just some of the main ones that we've kind of brought our data into, but pretty much any platform out there on the market that will take a point cloud in a universal file format like LAS, LAZ, E57, PLY, TXT, we can export our data into those platforms with almost no exceptions. Also, just some statistics we're very proud of. We have currently sold over 2,000 systems across 70 countries for over 100 different applications. And that's really quite an accomplishment. I'm sure those numbers are probably even higher as of last month when we posted them. So this technology is being used across the world for a variety of different applications. And here's just kind of a small sampling of some of the companies that are utilizing this technology. And it's pretty diverse, from mining companies to real estate companies to construction companies to universities. There are a couple of universities on here. Public sector, like I said, United States Postal Service is using our systems to document and create as-built documentation of all of their post offices, which is, I don't know, thousands, maybe tens of thousands of locations. So quite impressive technology being used by a lot of different companies across the world. And also just wanted to highlight GeoSLAM Care. This is our support and maintenance plan. This is kind of a crucial component of our systems. Once you purchase a system, this comes as sort of a default with it, but gives you up to 3 years of hardware warranty, ensuring that your system is always performing. Remote software support. If you have any issues with your software or hardware, we will support it, as well as software updates. Like I said, we're always updating our Connect platform and other platforms. So this gives you the ability to update your software continuously. We're also currently have a trade-in offer, and I'll read the details of this because I'm not 100% clear on the trade-in offer, but basically you can trade in any scanning device. Pretty much any SLAM or LiDAR scanning device is eligible for this offer. It can be from any manufacturer, but it doesn't need to be a GeoSLAM device, but we will do a trade-in for our own devices as well. Any physical condition or age, just as long as it's still functioning. You can't give us a pile of scrap and try to trade that in. But if you're interested, please message us at the end of this or reach out to us via the website, and we're happy to give you more details and see if you're eligible to trade in your equipment. We also offer demo in a box. We've been doing this for quite some time now. Basically, we will send you a demo system so that you can trial it yourself and kind of do the handoff and the unboxing training virtually. We prefer to do in-person demos if we can. They always seem to have a bigger impact, but if you are restricted in your ability to meet in person, then demo in a box is a fantastic option. So we've had good success with this program. Of course, follow us on social media: Twitter, LinkedIn, Facebook, Instagram, YouTube, etc. We're on all those social media channels, so please follow us for updates on the company. And I guess now we will open it up to any questions that we may have gotten. Again, feel free to type any questions that you might have in the chat. Let me stop sharing my screen. Beautiful. Sam, did we get any questions? Looks like we had about a 50-50 split on the initial question. Have you used laser scanning before? 55% said yes, and 45% said no. So glad to hear a nice diverse audience. Okay, so a couple of questions that came in. More coming in now. So let's start from the top, and anything that got marked. Here we go. Oh, wow, lots of questions. I'm not sure we'll have time to get to all of these, but we had a question from Jonathan. Which product would you recommend for scanning VR environments for reviewing? Depends which kind of VR environment you're trying to capture. In general, I would kind of point you towards the ZEB Horizon system, not really knowing exactly which environment you're trying to capture. But assuming this is kind of an outdoor environment and a larger scale environment, probably the ZEB Horizon would be your best bet, along with possibly a ZEB Vision camera to colorize that data as well. Another question from Grace. If I wanted to use the Horizon on a UAV, do I need to buy a separate product just for UAV? That's a really good question. So we actually just released, just to give you a general answer, no, you don't need to buy a separate product. What you do need is a way to mount it to that UAV. We have a variety of mounting systems to go on a lot of the commercial UAVs that are on the market, including DJI Matrice systems, Alta X-Fly systems, and have some mounting systems for more universal mounting to different UAVs or custom UAVs. But we did just release a mounting system for the Matrice 300, which is a bit smaller of a drone, a bit smaller payload. And in order to match that payload or meet that payload capacity, we did develop a separate data logger for that system specifically. So if you're using a Matrice M300 drone, then yes, you would have to buy that separate data logger to go with it. Kent asked if the slides can be shared after the presentation. I believe we will share this webinar recording after the presentation, and it will be readily available on social media as well as on our website. Can I use this on a car to use for topo surveys? Asked by Chad. Yes, short answer. yeah, it's definitely possible to use this on a vehicle for topo surveys. Again, restricted to about 20-mile-an-hour limit. But yes, you can take that data into a third-party platform such as Autodesk's Civil 3D and use that to create a topo survey. Many times you'll have to isolate just that surface. So basically clean out vegetation or trees or noisy points if you're on a roadway, probably cars and things like that, to just basically reduce it down to just the points that are on that surface. And then you can turn that into a topo survey. Recommended walking speed when operating the device, asked by Kent. So typical walking speed is fine. With a Revo RT, you want to go pretty much walking speed. I have pushed that to like a speed walk or even a light jog and been able to capture successful data, but we recommend just kind of your typical walking speed with the Revo system as well as the Zeb Go. With the Horizon, it's quite environmentally dependent as well. So if you're in a nice open environment with good features around you, you can travel at a speed of up to about 20, 25 miles per hour and capture good data. But if you're more of a confined space, like compartmentalized space, underground, things like that, you will want to slow down a bit. Basically, the more confined the space is, the slower you should move. And that's fairly universal for all of our systems. Yes, Kent, we will be sharing a recording of this. I believe I already said that. So, yeah, we will be sharing a recording. Is what we see from scans a millimeter level of accuracy. So across the board, right, we have two levels of accuracy. We have global accuracy, which is from one end of the capture all the way to the other. So if we're capturing a building, it'd be from one corner of the building all the way to the other. That's essentially the accuracy of the SLAM algorithm to stitch that data together. So that's typically a couple of centimeters. So sub-inch is what we're seeing typically in global accuracy when we tie into known control points. And then local accuracy. So if we're measuring like the width of this door behind me, that would be down to about a half an inch to a quarter of an inch. So centimeter, sub-centimeter level of accuracy for smaller measurements. And that's basically the accuracy of the actual LiDAR sensor. How would you go about scanning buildings in excess of 100,000 square meters? Well, you have to break it up into different sections. So typically we're running the scanner for about 20, maybe 25 minutes at a time. That's the best process for data management. And then when you're doing that, similar to a static scanner, you're going to create overlap between those different scans. So if you're doing a multi-story building, every floor that you'll tie into the next floor above it or the floor below it, creating that vertical loop and creating that overlapping data. You need about 20 to 30% overlapping data from one scan to the next to register them together. Same thing as if you're doing a big open environment or outdoor survey or something like that, create that overlapping data. You can also use control points. We can tie into control points using the Zeb locate system, using a handheld system. We have a base plate that ties into control points. You can adjust your SLAM to those control points, and we can use that to put data sets together as well, bigger data sets. That's kind of a simpler way to do it, assuming that you have control points on your site or a method to acquire those. All right, how are we doing on time? We still got about 10 minutes. How does the scanner create an image of the roof without going on top of it? Like if the user was scanning from street level? That's a really good question. So the scanner is line of sight, right? So if from the position that you're holding the scanner, you can see the roof and it's within the range of the scanner, you will capture that roof. So a pitched roof is fairly easy to capture. Sometimes you'll have to get the scanner up a little bit high, either by holding it higher or by using that extendable pole accessory that I mentioned before. Yeah, we can capture pitched roofs fairly easily. If you do not have if you have a flat roof, you will either need to go on top of that roof and create overlapping data or tie into control points to put that data together with your ground-based data, or you will need to use something like a UAV and fly the top of that roof to get data up there. So again, all line of sight. Unfortunately, we can't go over parapet walls or anything like that with the LiDAR sensor. All right, sorry, just reading through a couple more of these. Got a couple people interested in demos. That's great. All right. Any time estimates for LiDAR capture from a drone? It's kind of a big question, so it depends how long you can fly your drone for. Like I said, in general, we're scanning for 20 to 25-minute segments, which for a drone is usually kind of the top end. It depends which kind of drone you have. With the M300, we're actually tying into the power source of the drone and using that to power the scanner as well. So it does reduce that flying time a little bit. So it kind of depends, but typically, yeah, you're in that 20, 25-minute window of time with the drone capture. And if you needed to capture a larger area, you would tie those together using overlapping data or control points. Understand you can use GeoSLAM for change detection. How does this work, and does it cost extra? So, good question. We can use GeoSLAM for change detection. Basically, we're comparing a scan from one time to the next, and basically figuring out what's different and what's the same between those scans. And we can also highlight areas that have changed or not changed, so you can monitor what's different from one scan to the next. It is something that is included in the Connect software. So if you are on GeoSLAM Care or you're purchasing a new system, you are eligible to upgrade to the GeoSLAM Connect software, and that does not cost any extra. When is Zeb Vision out? I would love to know that as well. It's supposed to be out at the beginning of the year, so keep an eye out for updates on Zeb Vision. Can we colorize the point cloud? Absolutely. Using Zeb Vision, we can colorize. We also have kind of a more traditional method of colorizing with Zeb Cam, as well as our Discovery system. Didn't talk about it very much, but the Discovery system is a backpack system with a 60 megapixel, really high resolution camera built into it. And we can do very high resolution colorization, more like photorealistic colorization of the data using that. The Zeb Vision, as I understand, kind of sits in between those two. All right, we got another few minutes, so I'll just take a couple more questions. Oh, looks like there's only 2 more on the list, so get them in if you can. How does this data mesh well with data from other systems? Example, I want to utilize, I'm not going to mention the name, but a competitive system as well as a GeoSLAM system as a vehicle-mounted operation. Very interesting. So again, same kind of methods for putting this data together, right? If we're using a third party or a different instrument to capture data, then typically what we're going to do is use control points to tie those data sets together, which actually is the next question I'll address. But typically we're using control points to tie those together. And you can also possibly do cloud-to-cloud registration. So you could take a GeoSLAM capture, export it as an E57, and bring that into your registration software, whatever software you're using to register that, like static scan data or a third-party application that can do registration and actually do cloud-to-cloud registration. So there's various techniques to put it together, but those are kind of the 2 main ones. How do we tie into control points? Okay, so I mentioned this briefly. Our systems they come standard with a base plate, a reference base plate, which basically sits on the bottom of the system. I wish I pulled my system out. It's right next to me. So you set the scanner on this base plate, and then as we're scanning, we can take the system and set it down on top of a known control point. That base plate has a crosshair in it. And that's basically directly below the phase center of the scanner. So we're calculating the offset down to that crosshair and basically marking a reference point in the data. That then in post we can tie control points to those reference points. So basically move our data set onto that global coordinate system or site coordinate system or whatever it is, based on those control points. What we can also do is we can modify our data. So actually run what we call a non-rigid adjustment to those control points, and basically run SLAM algorithm again, prioritizing those control points and fitting those. So even getting a little bit better accuracy across the board, assuming that our control points are like centimeter level accuracy or better. All right, I think that's it. If you guys have any last minute questions, feel free to drop them in the chat. I'll be on for another 2 minutes or so, but thank you guys all so much for attending, and thank you marketing team for putting this on and helping me out with this presentation. I really appreciate all the work you guys do. That's it for me. So thanks guys, and feel free to reach out to us if you'd like more information, like to schedule a demo, anything like that. Oh, one more question. What is the name of the backpack unit? So we have 2 backpack units. We have the Zeb Locate, which is a backpack with a GNSS receiver on top of it. And then we also have a Zeb Discovery, which is a backpack with a high resolution 60 megapixel camera. So it also does have a GPS built into it, but not very accurate. So yeah, that one's for colorization and visualization, and then the Zeb Locate is for geo-referencing the data. How does Zeb Locate communicate with third party? You guys are asking lots of questions. How does Zeb Locate communicate with third party GPS systems? RTK, things like that. Okay, so basically what we're doing is we're taking the trajectory of the GPS system and we're marrying it to the trajectory of the laser scanner. So part of the SLAM algorithm is actually producing a trajectory file, basically the path that the actual system moves through the environment. Essentially what we're doing is we're marrying those together, and then we're calculating the offset between the phase center of the scanner and the GPS that sits up above it, which is a defined offset because it's mounted on a backpack. There is potential to do this on vehicles and other methods, UAVs, things like that. As long as we know what that defined offset is, we can basically program that into our data. But that's a little bit more of a complicated workflow. All right, guys. I think that's it for questions. It looks like that's it for time. Thank you so much. I'm signing off. Please reach out if you need any more information, and we'll talk soon.